A tricky trigonometric question from NEST 2015. It is question number 12 in the set A PDF. Suppose root of 9 minus 8 into cos of 40 degrees is equal to a plus b into sec 40 degrees, where a and b are rational numbers. Then mod of a plus b equals half 3 by 2, 2 and 3. Acha. Now look, this is a root of 9 minus 8 into cos 40, and on the other side we have got a plus b sec 40 degrees. Okay, degrees. The thing about this problem is if you square and then try to simplify that, you don't actually go anywhere, and the reason is very clear. We have got two unknowns here, a and b, okay, and we have only one equation at our disposal, so we need something else. Okay, and if you don't get it in the exam, if you don't get it, then I don't think there is any possibility that you will be able to solve the problem, but otherwise it is very simple. Okay, we usually in trigonometry problems what try to do is we try to relate the angle given in the problem with the standard angles like 0 degrees, 60 degrees, 30 degrees or 90 degrees or 180 degrees. Okay, if you realize 40 into 3 is 120. This single equation is the most important part of the problem, will not believe. Okay, 40 into 3 is equal to 120 is the most important part of the problem. How? Because we know cos 120. Okay, and we also know triple angle formula. So what can we do? Let's invoke the triple angle formula first. So cos of 3 theta is 4 cos cube theta minus 3 cos theta. Okay, now if you use that formula with theta equal to 40 degrees, then what can I say? I can say cos 120, which by the way is negative 1 upon 2, will be 4 into cos cube 40 minus 3 into cos 40. Okay, cos 120 is equal to negative 1 upon 2, that is 4 cos cube 40 minus 3 into cos 40. Now let us suppose that cos 40 is x. Well, you can call it x, but we know it is not any unknown. Okay, so we get negative 1 upon 2 is equal to 4x cubed minus 3x. Okay, negative 1 upon 2 is equal to 4x cubed minus 3x, and let us now shift this negative 1 upon 2 to the other side and multiply by 2. Okay, so multiplying by 2, this gives me 8x cubed minus 6x, and then the plus 1 equal to 0. Okay, and we now know that we have now got this cubic equation, and one of its roots will be cos 40. Okay, now let us go to the equation that they have given. Okay, that's what I wrote here at the beginning. Let's go to that equation, and I'm going to do two things here. Firstly, I will substitute cos 40 as x, which I did here. Okay, cos 40 as x, and then simultaneously I am going to square both the sides. So on squaring I will get well, that root will go here, so that will be 9 minus 8x, and on this side it will be a squared plus b squared sec squared 40. Cos 40 is x, so sec 40 will be 1 upon x. So that is a squared plus the second square plus 2ab cos 2ab sec 40, right? So that will be 2ab by x. Okay, squaring and writing cos 40 as x. Now we know that we should get the same equation. We should get the same equation after simplification. So what I will now do is I'll multiply the entire equation by x squared. So this will become 9x squared, this will become 8x cubed, this will become a squared x squared, this will become b squared, and this will become 2abx, right? Now let us shift minus 8x cube on the other side, so we will get 8x cube. Okay, we will get 8x cube plus bracket a squared minus 9x squared, okay, plus 2abx plus b squared is equal to 0. Okay. Now this is a cubic equation for which cos 40 is a root. Okay, cos 40 is a root, and this is another equation of which cos 40 is a root. Okay, now, well, we have to assume the equivalence between the two equations, because it could very well be possible that cos 40 is a root of another cubic equation. That is pretty much possible, but we have to write it, okay, or we have to assume that. What? Assuming that both equations are identical, okay, we get, what do we get? Let's equate the coefficients. 8x cube is there. There is no x squared coefficient, so a squared minus 9 is 0. That will give immediately a as plus or minus 3. Okay. 2abx, so ab will become negative 6. Oh no, sorry, 2ab is negative 6, right? So ab will be negative 3, and b squared will be 1. That's the constant term. B squared is equal to 1, so b is equal to plus or minus 1, right? Now, although a is plus or minus 3 and b is plus or minus 1, there aren't 4 pairs here, okay, because ab is negative 3, so one of them has to be positive and the other one has to be negative. So a3 b minus 1 or a negative 3 b1, they satisfy all the three, especially that ab equal to minus 3 part, this one. Okay, a and b, a3 b1 and a negative 3 b negative 1, they satisfy these two also, but they don't satisfy the central one, right? In that case ab will be 3, right? So what is mod a plus b in both of these cases? Here it is anyways 2. For the other one it is negative 3 plus 1, negative 2, mod negative 2 is 2. Okay, so mod of a plus b is 2. Option C. Okay, so see, now many times the question that we all have in our minds is, how are we going to guess the right step? Okay, how are we going to guess the right step? Trust me, if you solve enough MCQs, you will get some kind of vision, because whenever we see a new situation, what we try to do is we try to relate it with something that we already know. And for trigonometry problems, we know the basis. Our basis is our formula that are available, and secondly, the standard angles 0, 60, in this case 120, or in some cases, who knows, it could also be 45 into 3. Okay, we don't know that, so need to be ready with the such things in order to solve such interesting questions, right? Yeah, now what we can do is we can go back to this cubic equation and see what are its other roots. Are they real or are they complex with non-zero imaginary part? Okay, could be interesting to see that. Just go to equation, select the cubic equation 8. Now there is no x squared term, so I have to type 0 there. X's coefficient is negative 6, constant term is 1. Oh, nice. Okay, now look, what we have found is this equation's other roots are not complex conjugates. Okay, this equation's other roots are not complex conjugates. I think this cos 40 is x2, and I don't know what this is, but let's find it out. In that case, let's find it out. Okay, so first of all, what I will do is I will find out cos 40 degrees. Okay, cos 40 degrees. Yes, that's exactly the same value that we have got here, right? So that works. Now, will it also work for the other two roots? Okay, I'll leave that to you. You need to decide. You know the theory, then you will know the answer also, but let's find out the angles. Okay, let's find out the angles here. Okay, cos inverse of, let's take 0.1736481777. See, now I'm typing all the digits because, well, we might get the exact angle. That's 80. Nice. So this angle is 80. Okay, this angle is 80. And now let's find out this angle. Cos inverse negative 0.93. This will be an obtuse angle. 969 93969 262 0. Nice, that's 160. Okay, that is 160. So the angles are in GP. This is 40, this is 80, and this is 160. Okay, let's go back and let's go back to the problem and try to verify what happens if we put 80 instead of 40. Okay, so root of 9 minus 8 into cos 40. Okay, oh sorry, again went for 40, went for 40. That's 2.75. Yeah, whatever that is. Okay, whatever that is. Now I need to do the same thing for the right side. Okay, let us select A as 3 and B as negative 1. Anyway, if you take the other pair, it would just mean that it's negative, so that's fine. Okay, so 3 minus 1 upon cos 80. Yeah, okay, so we've got the negative 1. So for that, again there are two pairs, as it was the case for 40, and here it's pretty clear now that it's negative, so A negative 3 and B will be 2. Okay, sorry, B will be oh wait, yeah, so A will be negative 3 and B will be 1. Okay, okay, so let's also quickly do it for 160. Okay, 4.04. yeah, I think this, for this it will be positive both, so A will be positive, and because cos 160 is negative and B is negative 1, so that will give us the right answer. Let's check. Yes. Okay, now we have solved the problem, but we learned something new at the end because we verified that the roots were not well, complex conjugates, they are real numbers, and the roots shared an interesting relationships, right? They were cosines of angles which are in GP, like cos 40, cos 80, and then cos 160 degrees. So who knows, you might well, your brain will register this and it will bring it for you at the right time. Okay, so that's something new that we learned from the problem. Okay, all right, that was Nest 15 question 12.